Hey, what's up folks, how's it going? This is Watch. Hope you guys are all doing well, and today we're going to be talking about our first custom PC build of 2021. Now we're going to go with something a little bit more compact this time around, mainly due to the fact that I'm going to be moving this PC quite a lot between different spaces, and having a more compact PC is always going to be a little bit more convenient, especially if you want something super powerful that doesn't take a lot of desktop real estate. Furthermore, we're going to be using this system as a testbed platform to see what the graphical capabilities are using the latest PC hardware and directly comparing it against the current gen consoles that are available right now. We're also going to be comparing this relatively compact PC with the M1 Mac Mini, which is getting super popular right now. So if you haven't done so, please make sure you have subscribed and have post notifications turned on for our channel. Now, in terms of the components that we're going to be using, talking about the processor specifically, we have to pretty much go AMD. These days, compared to Intel, they're kind of winning in terms of the CPU wars, and we're going to be specifically using the Ryzen 7 5800X. It's an 8-core chip with 16 threads, 3.8 gigahertz on all the cores from a base clock frequency, and it can boost a single core up to 4.7 gigahertz, but you can easily overclock it to 4.7 on all cores. Now, in terms of RAM, I'm not going to need a whole lot to start out with since I'm mostly going to be gaming with this PC, so I'm going to go with 16 gigabytes of Corsair LPX 3600 megahertz memory, something I have lying around in the office. Additionally, in terms of the motherboard, we're going to be using the B55 Oros Pro AX from Gigabyte, and like most of the 500 series boards, you have full support for 3rd generation Ryzen CPUs out of the box or through a BIOS update. And the cool thing about this board is that you can actually upgrade the BIOS just using a USB thumbstick and not actually having any CPU or RAM installed, which is definitely convenient if you have a CPU that may not work right away without a BIOS update. Now, this ITX board has 8-phase digital VRM with a 90 amp smart power stage. There's also a lot of multi-layered heatsinks as well as a thermal backplate to keep the board relatively cool, and you have 2 M.2 connections. One is Gen 4 rated at the front of the board and the rear one is Gen 3 rated. You also have plenty of SATA connections. There's also plenty of I.O. at the back, including 6 USB 3.2 connections, including one that's USB Type-C with a Gen 2 interface. You also get a 2.5 gigabit Ethernet connection, as well as an Intel AX 2x2 Wi-Fi adapter alongside Bluetooth 5. Now, in terms of the long-term storage, we're going to be starting out with a WD Black SN750 M.2 SSD drive. We're getting the 500 gigabyte capacity over here. We will upgrade to something a little bit larger or a secondary M.2 drive if necessary, but this should give us at least 3 and 2.5 gigabytes a second in terms of read and write performance, which is going to be plenty fast for us, and we'll do some benchmarking later on in this video. Now, in terms of the graphics card, as you all probably know, due to the situation going on in the world right now, it's super hard to get your hands on anything relatively new in the AMD or NVIDIA side, and Zotac was kind enough to supply an RTX 3060 Ti for us. These cards are fantastic for the price to performance ratio, although the price right now isn't great due to the fact that there's a big GPU shortage. But once the supply to demand issue gets kind of settled, hopefully soon down the road, this is probably one of the best mid-tier NVIDIA graphics cards on the market right now, utilizing the 2nd generation ray tracing cores as well as the 3rd generation tensor cores found on other 3000 series GPUs. And specifically with the Zotac card, you're getting an Ice Storm 2.0 dual 80mm fan, as well as a beefed up heatsink with a wraparound metal backplate. Now, just for your reference, I'll throw up the specifications for the 360 Ti compared to the 370 as well as the 360, just to give you guys a little comparison. And in terms of the CUDA core, ray tracing, and tensor core count, it's actually closer to the 370 than the 360. And in terms of the FTP float point precision performance, you're looking at about 16.2 teraflops on the 360 Ti versus 20 teraflops on the 370 and 12.7 teraflops on the standard 360. Of course, later on in this video, we're going to be taking a look at the benchmark results of the RTX 360 Ti in both synthetic and some real-world gaming examples. But before we get into that, let's talk about the case that we're going to be using to house all these goods, and that's going to be the Fantex Evolved Shift 2. This is an all-metal ITX chassis that is vertically oriented. That way, you can utilize a lot of components inside the PC, but only take about 27 by 17 centimeters in terms of actual desk space. And thanks to the fact it's using a PCI Express Express riser cable that mounts the graphics card opposite to the motherboard. You can fit large graphics cards up to 335 millimeters long and 2.9 slots wide. And in terms of cooling your CPU, you can either go with a standard heatsink up to 85 millimeters in terms of height, or a all-in-one liquid cooling solution like we're going to be using from Deepcool that utilizes a single 120 millimeter radiator. Now, in terms of storage options, you can house two 2.5-inch SSDs with the included mount and a single 3.5-inch hard drive up top. You can also opt to get another one of these dual SSD carriers to replace the mounting point of the 3.5-inch hard drive. Furthermore, this version of the Swift 2 comes with tempered glass anodized aluminum side panels, so you can see what's inside your case, which is pretty cool. And there's mesh ventilation all throughout the case at the top, sides, and bottom, and you can set your airflow to either have ventilation go to the top or sides depending upon your needs and preferences. Now, in terms of the power supply, you're going to need to use an SFX or an SFXL PSU. I'm specifically using my old trusty Silverstone 450 watt PSU. I've had this for many years, but I would recommend upgrading to 500 watts or more, and there's definitely better options out there. We'll have some in the description down below. Now, the actual build process of the PC was relatively uneventful. I basically had no issues in putting everything together. Cable management's always a challenge with a case like this that's so small, but I'm going to be working on it later on once I get everything a little bit more tweaked and refined. But I had one major concern that actually took a couple of days to solve. When I initially plugged everything in, did the initial boot up for the first time, and got welcomed with a blank screen. Now, a whole host of things could be wrong. Perhaps I didn't get the right RAM, the CPU, GPU, or motherboard could be the underlying issue, or maybe perhaps the motherboard BIOS update wasn't made properly to work with the 5800X. I checked the RAM, I swapped out the CPU for an older generation Ryzen processor, and found out that it was posting correctly. Everything worked on the system itself, but as soon as I go to the 1500X, I would get no video signal, but it was actually posting since I could turn the num lock and caps lock on and off. Just wasn't getting any video signal through the graphics card. And after some more digging, I found out that the Fantax PCIe riser ribbon connection that I have with this case doesn't actually support X16 Gen 4 signals. Either you have to find yourself a Gen 4 compatible PCI Express riser cable, which is actually very difficult these days, or set the PCI Express connection to Gen 3 settings. And on the Gigabyte motherboard, what we have to do is plug in the graphics card directly onto the board, go into settings in the BIOS, miscellaneous, and PCIe X16 slot configuration, and set it to Gen 3. And once I did that, the riser cable did work, and I could complete the build. Now, in terms of the performance loss from Gen 4 to Gen 3, based on some of my experience, I didn't really find any performance loss using the card in a Gen 3 configuration. And perhaps later down the road, when software and games utilize the extra bandwidth available in PCI Express Gen 4, that difference will become more apparent. But hopefully by that time, I'll upgrade to PCI Express riser cable that can actually carry the Gen 4 signal. Now, moving forward, let's talk about the actual performance results coming out of this PC, starting with our CPU benchmark results from Cinebench. Now, we're going to be taking a look at the standard clock speeds, as well as where we've overclocked all the cores to 4.7 gigahertz with a core voltage setting of about 1.325 volts. Now, at completely stock settings, our single core score is around 1600 and our multi-core performance score is around 15,200 points. Now, with 4.7 gigahertz set to all cores, we're looking at a slightly lower single core score, about 1550 points, but a slightly higher multi-core performance score of just over 16,000 points. In terms of the Geekbench results, our standard core clock settings are 1600 points on the single core and about 10,184 points on the multi-core performance. With the overclock to 4.7 gigahertz on all cores, you're looking at 1600 again on the single core performance, and a slight bump up in terms of the multi-core at 10,297 points. Now, in terms of the CPU temps, at idle, you're looking at a range between 30 to 47 degrees Celsius, and at lows, you're looking at 65 degrees with a peak of 84 degrees Celsius based on our experience. And the CPU can certainly get very hot, and this is probably not the most optimal situation for an overclocked PC due to the fact that we only have a single 120mm radiator with 2 fans just cooling it. So you probably want to stick to stock frequencies from a long-term stability perspective, which is perfectly fine, and the performance that you're getting at overclock, specifically with this configuration, is going to be quite negligible. Now moving forward, let's talk about the graphical capabilities of this PC, and more specifically, the RTX 360 Ti from Zotac. In terms of 3D Mark's Time Spy Extreme, we're getting a score around 5662. Next, looking at Unigine's Superposition 4K benchmark set to high texture settings, we're getting a score about 9507, as well as an average frame rate of 71 frames per second. And at Valley Benchmark, we're specifically using for this system a ultra-wide Acer monitor, which has a native resolution of 3840 by 1440. And at that resolution with ultra details enabled, we're getting an average frame rate of about 124 frames per second. Now, in terms of our real-world gaming benchmark results, I only had time to test out one game so far, but it's a game that everyone is talking about, either good or bad, and that's Cyberpunk 2077. Now, with ray tracing turned off and our monitor's native resolution of 3840 by 1440, maxed out details and deep learning super sampling set to performance, we're getting an average frame rate of 62 frames per second with a 1% low of 48 frames per second. Now at full HD settings, 1080p, you're looking at 84 average frames per second and a minimum FPS rating of about 58 frames per second. Now with ray tracing turned on, this is where the system definitely starts to struggle, especially at the 3840 by 1440 resolution. We're only getting around 38 average frames per second with a minimum of 28 frames per second. At 1080p, things become a little bit more playable at 62 frames per second and 47 frames per second as a 1% minimum. But besides that, guys, that's really it for now. This PC is definitely still a work in progress. We're going to be tweaking some of the settings and perhaps some of the components later down the road, because this PC is essentially going to be our test bed for comparing what a PC can do compared to the current generation consoles from a gaming perspective, as well as productivity and overall performance perspective, while comparing to other popular smaller compact PCs. Now we're going to be doing a direct comparison again, as we mentioned before, with the M1 Mac Mini. So again, make sure you have post notifications turned on and subscribe to the channel to get all of our latest updates. And if you have any specific questions, definitely let me know. Check out the description down below where you'll find links towards all the components we talked about. And of course, if you use any of those affiliate links in the description, it gives us a little bit of kickback, helps make content like this possible in the first place. I want to thank you guys so much for your support, and we'll see you real soon in the next one. Take care.